Hello and welcome to another video. Today we're going to be continuing on with the Typescript challenge, and we are going to be doing binary tree level order traversal. So in this problem, you're given the root of a binary tree and you want to return the level order traversal of its nodes values left to right. So for the first level, we just have node 3, so we're going to have an array with node 3. For the second level, we have 9 and 20. For the third level, we have 15 and 7. Okay, and pretty much that's what it is. And then for the second example, if you have just the root with a value 1, you just want to have 1. And for an empty tree, you want to have nothing. So how do we do this kind of problem? Well, let's just write some values. So let's say we have 3, 9, 20. Let's write a few values, right? So 15, 20. Maybe you can fill this out like 3, 10 or something like this, right? So we want to go level by level, but how do we actually ensure that we go level by level and that we also go left to right? So that part is going to be reasonably straightforward. We're just going to have an algorithm that's going to take in a node and a level, and we can simply make sure we visit the left side before the right side. So what that's going to look like is we're going to start at level 0. We're going to take in this root node, and then every time we go down, we're going to add 1 to the level. And then we're going to have a result. So let's just have a result here. It'll be a result array. It'll start with nothing. And simply what we're going to do is when we try to add a value, we're just going to check, does that level exist? If yes, let's just append to the right level. And if no, then let's just add another array in this array to represent the level. So what that's going to look like is we're going to start at 3. We're going to say, okay, does level 0 exist? Like, is there actually a 0 index in this result? No, there's not. So let's just add an array, an empty array, and then let's finally put in the value. So we're going to put in 3. Then we're going to go, remember, we want to go left and then right, right? So we're going to go down here. This will be level 1. We just add 1 to the level. It's going to be a recursive function. And we're going to say, does level 1 exist? Is there a 1 index here? No, there's not. So we're going to add an empty array. And we're going to add the value 9. And then we're going to recurse again, right? So we go value left, right. So we recurse down here, level 2. And does this level exist? No, it does not. So we will add a 15 here. And then we recurse again. 20, 3. Let's actually get rid of, or let's actually move this a little bit just to give us more space. There we go. And let's get rid of this. We'll have a closing one later. Okay, so does level 3 exist? This is level 0, level 1, level 2, level 3 does not yet exist. Once again, let's make an empty array, and let's add level 20, or number 20. Now we recurse back, because there are no, we don't need to check null nodes, right? So we recurse back up, recurse back up, recurse back up. Now we do the same thing for the right side. This is level 1. Does level 1 exist? Yes, it does. So let's add 20 to that array. Let's just push it to the end. Then let's go down here. This is level 2. We'll check the left first. Remember, we want to go left to right. So level 2, does 3 exist? Or does level 2 exist actually? Yes, it does. So let's add the value 3. Then we recurse back up, recurse back down here, level 2, and we want to add the value 10, and there is a level 2. So this would be essentially our answer for the result. So pretty straightforward. You literally just recurse and you add 1 to the level every time, and you want to make sure you go to the left side before the right, and that will ensure that all your stuff is written left to right as long as you visit the left and the right. So now we have enough to be actually coding it, so let's do that. So here it is. We can full screen. So first thing, we're going to have this result array, and it's going to be a number array, a two-dimensional array, right? Because it's going to be an array of arrays. Then we're going to have a traverse function. So it's going to be traverse. We can also write it in here, I guess, but I'm just going to make a helper function. So it's going to take a node that will be either a tree node or null. And then we will have level, which will be a number. And it will return a void. So the first thing we can check is if the node's value is null, or if the node does not exist, right? So if the node's null, we can just return straight away. So we can say if not node, let's just return because we don't need to add it to the traverse list. Okay. Now we need to check, does the level exist? So there's two cases that can happen. the level either does exist, or, for example, if we're at level 2 and the level doesn't exist, level 1 and 0 have to be in the array because we would have added the nodes already. So that would mean the array would be length 2, and then the level would be 2. So if the level equals the array's length, that means the level does not exist. So we can check for that. So we can just say if level equals result.length, that means the level does not exist. Let's just push an empty array. And then finally, regardless, now that we do have that level, now we can just say res level dot push the value. Then we simply need to, like I said, we want to go left first, so traverse dot left level +1, and you could also do null checks here if you wanted to, but this should take care of it by having this thing right here. And then we will traverse node dot right. And the reason you want to write types in a lot of these is because this can be tree node or null, so it's important to give a type. So just kind of like focusing on the TypeScript side of things, you want to specify a type when your stuff can have multiple things. Like for example, this res empty array, well, this could be all kinds of things, right? It could be something like this, and it could also be a number array. It could be literally anything, right? So when you give it an empty array, you're not really saying what type it is. But if I made my result equal to this to begin with, right, if I said result equals this, now I know that, okay, it's a string array. But because I made an empty array, I want to give it a type beforehand. Same thing here. You don't really know what inputs you're going to have, so it's kind of a good practice to give inputs to your types and your output and things like that. But for other things that, you know, like if you make like something equal to, say num equals 5, you don't really need to give a type there because you're basically saying it's 5 already. So just some good TypeScript things to think about. Okay, and so now we need to call traverse, and we need to give it the root. And the starting level is 0, right? We're going to start at level 0, and then finally we need to return this result array, or this nested array. So let's try to run this. Happens here. Okay. And you can see it's reasonably efficient. It's all over the place with TypeScript, so honestly I don't really pay too much attention to the runtime and things like that. So for the time, we are essentially looping through our entire tree, so that's going to be O(n). And for the space, you can have your tree completely right side focused, right? So let's say you have the root node and every node is just a right node. So it'll be like tree, and then you keep going right, you don't have any left nodes. So your tree is essentially like a linear tree, it's not a tree at all. That would make the recursive call stack the entire tree, which would be O(n), even if you don't count the result as part of the output. But yeah, that's going to be it for this problem. Hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.